All right, so today we're going to be incorporating mass times velocity into our conversation. So we're going to start with an example, classic example we've been using. So let's say a bowling ball has a mass of 7 kilograms and initial velocity of 2 meters per second to the right. It's a slow roller. And the bowling pin has a mass of 4 kilograms initially at rest. Right after they collide, the bowling ball is now going 0.25 meters per second to the left. So it bounced off. You ever had that happen? Like little kid rolls it down and doesn't hit it so hard it actually bounces back and is in the gutter. Okay, gotta get someone to go get it. How fast the pin going after going and in which direction? Okay, so here's how to bake a conservation of momentum problem. I'm going to walk you through these steps right here, okay, verbally. So, step one is define your system. What objects are in your system? For this one, we're going to put the ball and the pin. Okay? Step two, we're going to pick which way to be the positive direction. Okay? I would tend to say whichever way more things are moving, make that the positive direction. You're not going to get anything wrong because of that, but so I'm going to say the bowling ball is moving to the right, so I'm going to say to the right is the positive direction. Okay. Step three is determine, hey, is momentum conserved or not? So in this case, bowling ball, bowling pin, there's no unbalanced external forces. So we're just like, yeah, momentum is conserved. So that sets us down this path of total momentum of the system initial is equal to total momentum of the system final, which is the momentum of the ball initial plus the momentum of the pin initial is equal to the momentum of the ball final plus momentum of the pin final. Everybody tracking so far? This is, that's where you stopped last night on the worksheet. We're going to go a step further and say, remember that momentum is equal to mass times velocity. Okay. Now, here's a side note that's really important. If you are given a value, like a number, for velocity or momentum, then you must assign positive and negative sign to them. You must assign positive and negative sign to them. This side note right here, this is why you're going to miss the problem and get it right. To show you what I mean by that. So, the bowling ball has a mass of 7 kilograms and has a initial velocity of 2 meters per second. So 2 meters per second, that is a value, that's a number I've been given. That's a velocity or momentum. I need to assign a positive or negative sign to that based upon what I said was positive and negative. So it's to the right, so that's positive. Now, technically, you don't have to stick that in there. I'm just trying to teach you. Okay. Pin is at rest, so that's 0 momentum initially. Finally, the ball still has a mass of 7 kilograms and is now moving 0.25 meters per second. So this is a number of value of velocity and going to the left. So because of this, I need to make that negative. That's essential. This is why you're going to miss the problem or get the problem right. Guess what's going to be on multiple choice? The answer with this and the answer without that. The most popular wrong answer is going to be the one that you forgot to put the negative sign there. That is, you must assign a direction to velocity or momentum if you're given a value. Are we okay with, does that make sense? And then here, we've got 4 kilograms for the mass of the pin, and final velocity is unknown. If you are solving for velocity or momentum, then don't assign positive or negative sign. It will be revealed in the answer. Okay, it'll be revealed in the answer. So, right here, this is what I'm solving for. I'm not going to say is that positive or negative. I might have a hunch, I might have a guess. I think it's going to be, but I'm not going to do anything with that sign because I'm solving. So if you have a value, you have a number for velocity or momentum because they're vectors, you must assign a direction. Good? Okay, that's the setup, and we just solve for it. Okay, it's not, this is as hard as it gets. Okay, so I've got 14 is equal to negative 1.75 plus 4. So I got 15.75. So my final velocity is 3.94 meters per second.
But if you want a more precise number, you have 3.975 meters a second.
Good, but this is good enough. 3 sig figs, perfect. What is the sign of the answer? Positive. Okay. Now, here's what I'm going to have on the test. Is I'm not going to say positive or negative because you have the freedom to choose which way is positive or negative. I'm going to say 3.94 meters per second to the right because positive corresponded to the right. So here's what your choices are going to be on the test. Right, I'm just telling you straight away. It's going to be 3.94 meters per second to the right, 3.94 meters per second to the left. And then the answer of if you forgot to put this as negative, it'd be whatever the wrong answer is to the right and that wrong answer to the left. Those are your choices. Okay. I just told you what your test is going to look like. Okay. But for some reason, it's not 100%. Okay. But is everybody good? So those are your, and then make sure this corresponds to life. Would we expect the pen to be going to the right after it gets hit by the bowling ball? Yes. Okay. All right. So there are your choices. Can you read through that? The dry erase marker. Was velocity conserved?
No.
Well, it started. It started with 2 meters per second, and it ended up with negative 0.25 and 3.94 was velocity conserved. Velocity is not conserved. Momentum is conserved. You ended up with more velocity than what you started with, but that's okay because it's not. That's not what's conserved. Momentum is what is conserved. Okay. You don't let that derail. Like, oh my goodness, there's more velocity than what we started with. It's true, but not more momentum than what we started with. Okay. All right. The second example. Any questions there? Points of confusion. All right, a big 5 kilogram fish is swimming at 6 meters per second westward towards an absent-minded smaller 2 kilogram fish swimming at 3 meters per second eastward. When the 5 kilogram fish swallows the 2 kilogram fish, what is the 5 kilograms fish's velocity immediately after lunch?
So basically,
Okay.
how fast does the blue get?
So let's just be honest. Dory would not make it past adolescence. Like, I just.
Yeah, big mouth fast fish.
Okay.
That's a blue gill.
So, step one, pick our objects, our system, big fish, small fish. Step two, pick the direction it's moving to be positive. Now, if I were in your shoes, I would say westward to be positive because that's the way I think things are going to be going. However, I'm going to choose eastward to be positive just to teach you something. Okay? So I'm going to make east the positive direction. Okay? So I'm going to have the momentum of the big fish initial plus the momentum of dory initial is equal to the momentum of big fish final plus the momentum of dory final. Okay with that? So initially, the big fish has a mass of 5 kilograms and has a velocity of 6 meters per second. That's a velocity that has direction. I need to assign that based upon what I've got. That is a negative 6 meters per second. Plus momentum of dory is 2 kilograms times her initial velocity of 3 meters per second. Going eastward, I made east positive, so I need to assign a sign to that. Afterwards, big fish is still 5 kilograms times some unknown velocity. Plus dory, 2 kilograms. Question: Does dory have momentum after She's eating. Okay. This would be if Dory had no momentum, had zero momentum, the speed was zero after she was swallowed. Here's what it would look like. Just keep swimming. Does that make sense? That would be zero momentum. She would not be moving. So either the big fish's digestive tract was like extraordinary, or we just blew out the tail of the big fish. What really happened was, does Dory's carcass have momentum? Yes. Does that make sense? How fast is Dory's body going? Same as the big fish. Are we catching? Does that make sense? Okay. So you can either write it like this, or you can write it like this. Big fish with a full stomach. Does that make sense? Either way is fine, unless I'm asking for what is the change of momentum of just Dory's. Then you need to like separate that out. Just looking for Dory. Okay? So either way you do it, doesn't really matter. You got 30 plus 6 is equal to 7. Final velocity. So you have negative 24, 7. So you have negative 24 sevenths meter per second. Good with that? 3.43. Okay. Now, what does that communicate? Direction, which is what? Westward. So you would say westward. Okay, so the right answer would be 3.43 meters per second westward. A wrong answer would be 3.43 meters per second eastward. And then the other two wrong answers would be forgetting to do the negative sign here, whatever the wrong answer is, eastward, whatever the wrong answer is, westward. That, like assigning those, that is where you're gonna get tripped up, okay? Good? Tell your neighbor. Correct answer is? Because they are together, they both have the same velocity. C. That makes sense? Stuck together, moving together as one. Okay? All right, next question. Have a conversation. Okay, for the sake of time, I'm going to reduce your suffering. Correct answer is D. What do you need? Need their mass. Does that make sense? Okay, so next slide, I'm giving you the mass. Tell your neighbor, tell them how you got to the answer. Correct answer is A. Because 200 divided by 70 is greater than 140 divided by 100. Last question. Thumbs up when you got something. Correct answer is? Nope. Correct answer is B, Maverick. Because they're both going at the same velocity, the Maverick has more mass.
So you're looking at the momentum levels,
What is that?
slower.
They're both moving the same velocity because they're connected. Good with that? Got a worksheet due tomorrow.